Good day all. In the last presentation, we learned about the Global System for Mobile Communication, abbreviated as GSM. In this presentation, we will learn about cordless telephone system. A cordless telephone or a portable telephone is a telephone in which the handset is portable but able to be used like landline phone communication. Only it operates by radio frequency transmission and not a physical insulated wire or telephone line. In this session, we will cover in detail about the cordless phone systems, architecture, different types of cordless technologies like CT0, 1, 2, and DECT. Finally, we conclude after learning about WLL. This is the outline of this presentation. Now let us begin with the introduction of cordless systems. Cordless telephone systems are full duplex communication systems that use radio to connect a portable handset to a dedicated base station, which is then connected to a dedicated telephone line with a specific telephone number on the public switched telephone network (PSTN), as shown in this diagram. Unlike a corded telephone, a cordless telephone needs electricity to power the base station. The cordless handset is powered by a rechargeable battery, which is charged when the handset sits in its cradle. The first generation cordless telephone systems were manufactured in the year 1980. The portable unit communicates only to the dedicated base unit and only over distances of a few tens of meters. Early cordless telephones operate solely as extension telephones to a transceiver connected to a subscriber line on the PSTN and are primarily for in-home use. The second generation cordless telephones have recently been introduced, which allows subscribers to use their handsets at many outdoor locations within urban centers such as cities like London or Hong Kong. Modern cordless telephones are sometimes combined with paging receivers so that a subscriber may first be paged and then respond to the page using a cordless telephone. Cordless telephone systems provide the user with a limited range of mobility, as it is usually not possible to maintain a call if the user travels outside the range of the base station. Typical second generation base stations provide coverage ranges up to a few hundred meters. The following video clip illustrates the working of cordless phones. Now, to illustrate the parts of a cordless telephone, let us see the inside of this device from GE. This device was made in 1993 and operated in the 43 to 50 MHz range. As mentioned above, all cordless phones have a base and a handset. Let's look at these parts individually. Base. The base unit of the cordless phone is plugged into the telephone jack on the wall. If you open up the base and expose the circuit board, you see several components that carry out the functions of the base. The phone line interface receives and sends telephone signals through the phone line radio, amplifies signals to and from phone line interface, user controls and speakerphone if present, and broadcasts and receives radio signals to and from the handset. Power supplies low voltage power to the circuits and recharges the battery of the handset. The phone line interface components do two things. First, they send a ringer signal to the bell or to the radio components for broadcast to the handset. This lets you know that you have an incoming call. Second, they receive and send small changes in the phone line's electrical current to and from the radio components of the base. When you talk, you cause small changes in the electrical current of the phone line, and these changes get sent to your caller. This happens when the caller talks to you. Let us a look at the radio components and the power components. The radio components receive the electrical signals from the phone line interface and user controls. The radio components convert the signals to radio waves and broadcast them via the antenna. Radio components use quartz crystals to set the radio frequency for sending and receiving. There are two quartz crystals, one for sending signals and one for receiving signals. Remember that the base and the handset operate on a frequency pair that allows you to talk and listen at the same time. The radio components include an audio amplifier that increases the strength of the incoming electrical signals. A DC power cube transformer supplies the low voltage required by the electrical components on the circuit board. The power components on the circuit board work with the power cube to supply electrical current to recharge the battery of the handset. In addition to the above components, some bases also have audio amplifiers to drive speakers for speakerphone features, keypads for dialing, liquid crystal displays for caller ID, light emitting diodes for power charging indicators, and solid state memory for answering machine or callback features. Now let us take a look inside the handset. As you know, you can carry the handset with you throughout the house or outside within the range of the base transmitter. The handset has all the equipment of a standard telephone. The standard telephone comprises of a speaker, microphone, and dialing keypad. And additionally, the handset will have an equipment of a FM radio transmitter receiver. When you open up the handset, you see these components: speaker, microphone, keypad, buzzer or ringer, radio components, LCD or LED displays, rechargeable battery. The speaker converts electrical signals into the sound that you hear. The microphone picks up your voice and changes it to electrical signals. The keypad is used for input for dialing. The buzzer or ringer lets you know that you have an incoming call. The radio components amplify electrical signals to and from microphone and speakers and send and receive FM radio frequencies. The LCD or LED displays the indicator, the lights to show different functions. The rechargeable batteries supply electrical power to handset. The GE cordless phone that we dissected is from the year 1993. The modern cordless phones have same functions and much of the same hardware. However, many of the electronic circuits that were once achieved with transistors, resistors, and capacitors have been replaced with integrated circuits. This advancement allows the handset to be either smaller with the same functions or the same size with more functions. In summary, a cordless phone is basically a combination of a telephone and an FM radio transmitter receiver. Because it is a radio transmitter, it broadcasts signals over the open airways rather than specifically between the base and the handset. Because of this open broadcast, it is possible for other people to listen to your phone conversation by using a radio scanner. So an important issue and feature to look for in a cordless phone is security, and DSS offers the best protection against eavesdropping. CT1 stands for Cordless Telephone Generation 1 and is an analog cordless telephone standard that was standardized by the European Conference of Postal and Telecommunications Administration in 1984, and it was deployed in 11 European countries. The initial set of frequencies provided for a set of 40 duplex channels using 25 kHz separation, with the phones transmitting in the 914 to 915 MHz band and the base stations in the 959 to 960 MHz band. These frequencies overlap with those used by channels 120 to 124 on GSM cellular phones, and thus these original frequencies have been withdrawn from use for cordless phones in the countries that originally authorized them. CT1 Plus provided in 1987 for a set of 80 additional channels using the same technical standard with 885 to 887 MHz used by the phones and 930 to 932 MHz used by the base stations. While not part of the original GSM 900 band, the frequencies do overlap with the extended GSM 900 band. Thus, between the advent of digital cordless telephones and the desire to free up spectrum for mobile telephones, these frequencies are being withdrawn for use as well. CT0 is a term used for pre-CT1 analog cordless telephones that were deployed in a variety of countries with incompatible standards, mostly in the low VHF frequency range below broadcast band 1. Since 31 December 2008, CTA1 and CTA2 based phones are forbidden in Germany. CT2 is a cordless telephony standard that used in the early 1990s to provide short-range proto mobile phone service in some countries in Europe. It is considered to be more successful, and CT2 was also referred by its marketing name as Telepoint. This slide and the following two slides present the differences among CT0, CT1 and CT2 systems. The primary features that differentiate these systems are mobile frequency, duplex scheme, multiple access type, number of channels, spacing between channels, and modulation techniques. Here you will find the features of CT0. Here, the features of CT1 and CT1 Plus are presented for you to go through. Again, in terms of duplex scheme, multiple access, number of channels, spacing between channels, and modulation techniques applied. Here in this slide, you can see the features of CT2 and CT2 Plus. The duplex scheme is still TDD, and the multiple access type is TDMA or FDM, and the number of channels is 40, and spacing between channels given in kilohertz is 100 kilohertz. So these are the basic differences between these three standards. DECT stands for Digital Enhanced Cordless Telecommunications, although it is also known as Digital European Cordless Telecommunications, which makes sense because it is a standard that originated in Europe. It is widely used in wireless phone systems to connect the cordless phone to a base station. With the flexibility offered by cordless phone communications, DECT technology has become the major standard for this application, and DECT is now in use over 100 countries worldwide. Although DECT was originally intended for fast roaming between networked base stations, it is mostly used as a simple cordless phone system to connect phones to a base station or base point and enable roaming within the home, office, etc. DECT is based on time division duplex and time division multiple access with 10 carriers in the 1880 to 1900 megahertz band. It has a TDD/TDMA frame structure. The complete frame is 10 milliseconds in duration with 24 time slots. The first 12 slots are allocated for the transmission from base stations to handsets, and the other 12 slots are for the transmission from handsets to the base station. In the picture above, the yellow squares represent occupied time slots. A connection always uses a pair of time slots separated by one half TDMA frame. The DECT standard utilizes a common interoperability profile for simple telephone capabilities. This is called GAP, a generic access profile, which most manufacturers implement. The GAP profile ensures interoperability of equipment from different providers for voice applications. The GAP defines the minimum interoperability requirements, including mobility management and security features. It has different requirements on public and private systems. This means that the GAP is effectively the industry standard for a basic fallback speech service with mobility management. This basic service is not always used, but instead it forms the fallback that is always be available, especially when requested by a roaming phone, etc. DECT is well suited for both domestic and business use. Its dynamic channel allocation and digital voice coding provide a voice quality comparable to a landline, while its ability to handover between base stations make DECT a prime candidate for larger sites such as offices or industrial buildings. In addition to home and business use, several extensions to the standard enable DECT to be used as a public access service. Cordless terminal mobility, and a wireless local loop. The local loop is a circuit line from a subscriber's phone to the local central office. But the implementation of local loop of wires is risky for the operators, especially in rural and remote areas due to less number of users and increased cost of installation. Hence, the solution for its the usage of wireless local loop, abbreviated as WLL, which uses wireless links rather than copper wires to connect subscribers to the local central office. The wireless local loop architecture is a system that is responsible for connecting the subscriber to the PSTN with the help of wireless technology that utilizes the radio signals and thus providing the standard telephone services to the subscriber. Wireless local loop is the use of wireless communication link as the last mile or first mile connection for delivering plain old telephone service or internet access to telecommunications customers. WLL comprises of the following components. The first one is the PSTN, which is the public switched telephone network, a circuit switch network. It's a collection of world's interconnected circuit switched telephone networks. The second component is the switch function, which switches the PSTN among various WANUs. WANU is a short for Wireless Access Network Unit. It is present at the local exchange office. All local WASU are connected to it. Its functions include authentication, operation and maintenance, routing, transceiving, voice and data. It consists of the following subcomponents: transceiver, then WLL controller, and WASU stands for Wireless Access Subscriber Units. It is present at the house of a subscriber. It connects the subscriber to WANU and the power supply for its provided locally. Then we have AM and HLR. AM is Access Manager and is responsible for authentication. HLR is the Home Location Register and it stores the details of all local units. The wireless local loop technology means that the subscriber is connected to the nearest exchange through a radio link instead of through these copper wires. It eliminates the first mile or last mile construction of the network connection. Low cost due to no use of conventional copper wires. Much more secure due to the digital encryption techniques used in wireless communication. So some of the advantages of WLL are: it eliminates the first mile or last mile construction of the network connection, low cost due to no use of conventional copper wires, much more secure due to the digital encryption techniques, and highly scalable as it does not require an installation of more wires for scaling it. And some of the features of WLL are: it allows internet connection via modem, it has provides data service, voice service, and fax service. With this, we come to an end of this session. Now, I want you to do the activity that is shown in this slide. Post the solution in the discussion forum by creating a new thread. The questions listed are: I want you to list a protocol used for cordless telephone systems. Explain it in your own words. In which frequency range do the cordless phones mostly work? List down the drawbacks for cordless telephones. And among CT0, 1, and OnePlus and DECT, which is a fully digital cordless system. Explain. And finally, what is the range of cell diameter of DECT? Once you have posted your answers in the blackboard, you may leave. Thank you for listening. See you in the next presentation. Bye.